Hey everybody, this video is going to talk about how to find the inverse of a relation or a function. So one of the first things you have to do is understand what the definition of an inverse is. So if you have a relation that pairs the domain element x to a range element y, then the inverse is going to pair y with x. So in other words, here where we have the relation of xy, the inverse is yx. So that means your x and your y values are going to switch. They're going to trade places. And basically what an inverse is a reflection over that line y equals x. That's where your x values become your y values and your y values become your x values. It's a reflection over that line. So if both the relation and the inverse happen to be functions, then they are inverse functions. Okay, so to find the inverse of that relation, we're going to switch the x and y values. All right, let's go ahead and take a look at an example. So let's find, let me get my green color here. Let's find the inverse, and we're going to graph both of them. So if the relation gives us the points 0, -5, 1, -4, 2, -3, 3, -3. Okay, then the inverse is where the y values become the x values become the y values. In other words, your x and your y values trade places. So that's going to be -5, 0, -4, 1, -3, 2, -3, 3. All right, so let's go ahead and graph. Let me grab the purple. We're going to graph 0, -5, 1, -4, 2, -3, 3, -3. All right, so is the relation a function? That's the question. Is it a function? Well, in order to tell, we have to pass the vertical line test. As I move a vertical line from -infinity to +infinity, from left to right on this graph, I have to hit one value, 1 point every single time. As I move left to right, I only hit one value. It is a function because it passes the vertical line test. So taking a look at, let's go ahead and graph the inverse on this same graph. So -5, 0, -4, 1, -3, 2, -3, 3. Now, is that a function? Well, does it pass the vertical line test? As you move from -infinity to infinity, left to right, do you hit just one x value? The answer is no, because that -3 is mapped to 2. It's also mapped to 3. Okay? I want to point out that line y equals x satisfies all of these points. That's where our y values, y equals x. Notice the purple is, and the green functions, they are reflections over that line. Okay? Now let's do the same thing but with an equation. Okay, so when it says find the equation for the inverse and be able to graph both of them, all right, well, here's what I know. In order to find the inverse, I have to switch my x and y values. So if this equation, f of x is the same as y equals, I have 2x plus 8. So to find the inverse, I'm switching the x and y value. And then I'm going to go ahead and solve for y. So I'm going to subtract 8 from both sides. And then I'm going to divide everything by 2. So I have a half x minus 4 equals y. Okay, now, function notation. The inverse of f is the same as f to the -1x. Okay, notice that is inverse of f. That equals a half x minus 4. All right, so let's go ahead and graph our function of f of x equals 2x plus 8. That means my y-intercept is 8. My slope is 2, so up 2, right 1. Same as going down 2, left 1, And I'm going to just do a few things here. And I'm going to draw the function. Okay. Let me grab my orange. I'm going to graph the inverse. I go to 0, -4, because that is the y value, the y-intercept of that function. And the slope is a half, so up 1, right 2. Or down 1, left 2, however you want to think of it. Okay, and I'm going to graph that. Okay. All right, so I'm going to, very quickly here in green, draw that line. Maybe I'll make it dashed. That might help a little bit. And that is that line y equals x. That is the reflection line. Okay. So you'll notice the points say 0, 8 is a point on f of x. That means 8, 0 would be on the inverse of f. Okay, because your x and your y's switch places. Now, is f of x a function? That's the question. Is f of x a function? Well, does it pass the vertical line test? Answer's yes. It's a line. The orange, the inverse, is it a function? Answer, yes. It passes a vertical line test. When your both functions, when both equations, I should say, are functions, then they are inverse functions. Another way to figure out if the f of x, use the f of x to figure out if the inverse is a function. So I use the vertical line test on f of x to figure out if it's a function. I can use the horizontal line test on f of x to figure out if the inverse is a function. So that's also a quick way to do that. All right, let's do one more here. It says find the equation for the inverse. Notice here we've got a quadratic. All right, so for this quadratic, we're going to go ahead and graph it, and we're going to find the inverse. So I'm going to go ahead and graph this function. It has a y-intercept of 2. When I plug in 1, I get 7. When I plug in -1, I get 7. And here is the parabola. Question, is it a function? Answer is yes, because it passes the vertical line test. So yes, it passes a vertical line test. Now, let's go ahead and find the inverse of g of x. So g of x, it would be the same as, say, y equals 5x squared plus 2. Well, if I go ahead and ask you, is the inverse a function before we even find it? Well, do the horizontal line test on g of x. Does it pass the horizontal line test? So horizontal line test on g of x. The answer is no. So the inverse of g of x will not be a function. But let's go ahead and find that equation anyway, and then we'll graph it, and then you can kind of see what it looks like. So switch your x and y's. X equals 5y squared plus 2. I'm going to subtract 2. I'm going to divide everything by 5. And I get, well, I might just leave that x minus 2 all over 5. And then I've got to take the square root. So y equals plus or minus the square root of x minus 2 over 5. So the inverse is plus or minus the square root of x minus 2 over 5. Well, we may not exactly know how to graph that right now, but what I do know that if I have this line, y equals x, and that is our reflection line, then I can go ahead and graph some points. If I have 0, 2 reflected over that line y equals x, I get 2, 0. If I have the point -1, 7, that would be 7, -1. Notice this part, that's that negative square root part. And then if I have 1, 7, That becomes 7, 1 when I switch the x's and y's. Oh, missed that one a little bit. And that is the positive square root part. Okay, so notice, does the inverse pass a vertical line test? No. So therefore it's not a function. Confirms what we said before when we did the horizontal line test on g of x. Okay. All right. Hope this helps.